Today we are going to start with a new chapter, that is VOR, VHF Omnidirectional Range. The principle of operation of a VOR, principle of operation is bearing by phase comparison. Okay, as I said to you earlier that anytime when you are studying a radio navigational aid, the first and foremost thing is to understand the principle of operation. The ground equipment, that is the VOR station, will transmit reference signal, transmit a wave which is frequency modulated, and the carrier sub-frequency is 9960 Hertz, and it is frequency modulated with 30 Hertz. It is frequency modulated with 30 Hertz. Right? This particular wave which is transmitted is what we call it as a reference signal. Reference signal, and this wave is omnidirectional. So it transmits this wave, a frequency modulated wave, in all the directions, right? Understood? If I have to plot the polar diagram of this reference signal, polar diagram of reference signal, how will it look like? The polar diagram will look like a circle, because for example, if you light a bulb in your room and let's say 4 members of your family, this is the bulb, are standing, let's say 2 meters away from the bulb, all of you will receive the same strength of light, am I right? Because that bulb is transmitting omnidirectional, isn't it? So therefore, the polar diagram of this reference signal is going to be a circle, right? It is frequency modulated and transmitted in all the directions, that is why we call it as omnidirectional. So therefore, at any distance, okay, let's say 2 meters, I have said an example. When we are talking about the bulb, let's talk about the VOR now. Now, if you are 50 nautical miles here, 50 nautical miles, 50 nautical miles, 50 nautical miles, what will be the phase difference? Will there be any phase difference? No, because at 50 nautical miles, the distance traveled by these waves are the same. So therefore, if you have to compare the phase, there will not be any phase difference, right? You will receive the same phase. Okay, right? So now I will have another wave which is the variable signal. Frequency is from 108 to 118 megahertz. Out of this frequency, that is frequency of 108 to 118 megahertz, up to a frequency of 108 to 112, the VOR uses a frequency which is first even decimals, up to 112. Basically, why even decimals is that the frequency band of 108 to 112 megahertz is frequency shared with ILS. This frequency is shared with ILS equipment, that is instrument landing system. So therefore the VOR uses this frequency, so ILS will be using somewhat like ILS will be using 108.1 first odd digit. Okay, 109.3, okay, 108.7. Likewise, the ILS uses the first odd decimal. From 112 onwards, that is frequency greater than 112, okay, all the frequencies are used by the VOR. Okay, so frequencies, okay, greater than 112, okay, all used by the VOR. So now we will come back to the variable signal. The variable signal is an amplitude modulated, and the polar diagram is like the figure of 8. This variable signal is amplitude modulated with 30 hertz. So how is it achieved? Variable signal is transmitted by a horizontal antenna. As I turn this antenna 30 times in a second, the signal will rise up to a peak value, drop to value of 0, and it will rise again and drop like this. Am I right? So now it will form a kind of a figure of 8, isn't it? With the maximum value what you get in this side when it is facing this side once again, and thereafter maximum to minimum to maximum to minimum, that is 30 times in a second, and it will be looking like a figure of 8. So now if we combine the reference signal whose polar diagram is a circle, it will form like the cardioid. That cardioid will not have any null, right? Okay, will not have any null. Okay, let us say that this is a cardioid. In that, the signal strength, okay, if we say that it is 1, 4, 4 and the 7 ratio. The name of this cardioid-like structure is what we call it as a limacon, Limacon. The name which is given to this polar diagram is limacon. Okay, so now is I have just said now that the variable signal is rotating, right? The antenna is rotating. So therefore this limacon will rotate depending upon the orientation of this figure of 8, right? Depending upon the orientation of this figure of 8, that limacon is gonna rotate at 30 hertz once again. So now let us derive the direction or the bearing from this. If this is a station and you can be anywhere around this, your aircraft is flying anywhere around this, am I right? Okay, if I receive the reference signal, as long as the aircraft is at this same position, okay, what is going to happen is that I will receive the same phase, am I right? However, for that variable signal, as the antenna is rotating, okay, the phase is going to be changing all the time, am I right, for the variable signal? So therefore, if I compare the phase of the reference signal and that of the variable signal, at any point there will be a difference in the phase. Understood? At any particular point around this beacon, around this beacon, if my aircraft is flying, okay, the reference signal will give you a constant phase, whereas the variable signal, because of the nature that it is rotating, I will receive a different phase in different directions. Right, isn't it? So this phase difference is been compared. So now how do we derive the direction is that these two signals are made in such a way that there is no phase difference between the variable signal and the reference signal when one particular aircraft is aligned at the magnetic north. When they are at the magnetic north, they will be aligned. Okay? I will try to simplify that. Primarily, this also works on the principle of the lighthouse. How does the lighthouse work? Okay? Lighthouse, there is always a light which is rotating, as you see. If you have not seen in the actual lighthouse, you might have seen in the movie, right? There is a rotating light. Okay, so now what it does is that it will have a reference signal also and a variable signal. That means to say that at one particular time there will be a multi-directional, omnidirectional light which will be transmitted, and the rest of the time the rotating light is transmitted. So how does it work is when this rotating light is aligned with the north, that is the time that omnidirectional light is transmitting. So if an observer is there and the north of that light, there will be no time difference between the transmission of this omnidirectional light and the transmission of this variable light. Understood? Let us say the color of that omnidirectional light is white and the color of this variable light is green. So when what do I mean by aligning on the north is whenever this is the omnidirectional light, which is a white light, and this is the rotating green light, and this side is the north. When this light is coming towards the north, that is the time it will also light up. So if you are standing exactly at the north of that particular lighthouse, you will see both the white light and the green light shining all together, right? There will be no difference in time. Now, what I am going to do is, I am not there towards the north of this lighthouse. Let's say I am at 090. Any lighthouse will have a RPM which is mentioned in that. Okay? RPM. Okay. For easy understanding, let us say that it takes 1 degree for 1 second. Okay? 1 degree for 1 second. It rotates at 1 degree per second, 1 hertz. If you are standing at 090, after you have seen that omnidirectional white light, after how many seconds you will see the green light? After 90 seconds, because it takes 1 second to turn 1 degree. 1 second, 1 second, 1 second, 1 second, right? So therefore, you will see that green light after 90 seconds. So if you know the RPM, the rate at which the green light, rotating green light is rotating, I can find out from the time which has been elapsed since that white light has transmitted, then I can find out at what direction am I? Yes? Because there is a difference, isn't it? This is what is the lighthouse principle. Similarly, if the VOR station is transmitting, there will be no phase difference between the reference signal and the variable signal when they are exactly aligned with the magnetic north. Thereafter, what is they are aligned, no phase difference at the north, magnetic north. So as the antenna rotates, if you are standing here, depending upon the direction at which you stand, there will be a phase difference. There will be a phase difference. And in a phase, when we talk about the one complete cycle, there are 360 degrees, right? One complete cycle, there are 360 degrees. So when you are standing at 90 degrees, 090 direction, there will be a phase difference of 90. When you are at 180 direction, there is a phase difference of 180, and you are standing at 270, there will be a phase difference of 270 between the two signals. So by finding out the difference in the phase, let us say you are at, there is a phase difference of 215. That means to say that you are in a direction of 215. The bearing, your bearing from that beacon is 215. So now we have learned how to find out the bearing of an aircraft from a VOR station. That was the working principle of a VOR. Thank you for watching. And if you're watching it for the first time, kindly subscribe, like and share this video with your friends. See you next time.